right, so let's look at number 21 in your packet. This one says the set of directions at the top of the page ask you to find the slope. Now, remember what that word slope means. Okay, slope is just a fancy way of saying find the derivative of the curve at the given point. Okay, so let's just start by taking the derivative. Now, we have been doing derivatives with regards to implicit differentiation, so we're going to do the same thing here. So I'm going to take the derivative of x squared, which is 2x, plus, and then I'm going to take the derivative of y squared, which is 2y, but remember, when you take the derivative of a y, we always write dy dx equals, and then the derivative of 25, that's a constant, so the derivative of a constant is always 0. Okay, so the goal really at this point is just to get this dy dx by itself, because that is just a fancy way of saying slope or derivative. So I'm going to start by subtracting that 2x over, and I'm going to get 2y dy dx equals, and then on the right hand of the equal side, I'm going to have negative 2x. All right, next thing that I have to get rid of is the 2y, so I'm going to divide out that 2y. So now I have that dy dx by itself on the left-hand side, but don't forget we can simplify these. We're going to keep the negative though. So my dy dx is negative x over y. Okay, that's the derivative, aka slope. So when it's asking you to find the slope, that's what we have here, of the curve at the given point. So now what we're going to do is we're going to take this point, which has an x value of 3 and a y value of negative 4, and hopefully you guessed it, we're going to plug it in there. All right, so the way that we write that is we do a vertical line like this. That's like an evaluate line. So we're going to evaluate that derivative, and then at the bottom we write what it is we're evaluating it at. Okay, all right, so then all I'm going to do is I'm going to take this 3 and I'm going to plug it in here. I'm going to take that negative 4 and I'm going to plug it in there. And then that's it. So the x already has a negative in front of it, and then the x value is 3. Y is negative 4. Okay, so last step. So my dy dx, when I evaluate it at 3 comma negative 4, is 3 over 4. And this would be my answer. Okay, just again, reminder, negative over negative is a positive. Dy dx is really the slope at the given point is 3/4. And that's it. Alrighty, so we're going to do the same exact thing with number 26. So this is number 26 in your packet at the bottom of the page. Obviously, you can see that the function's a little bit more complicated than 21, but that's okay. So I'm going to take the derivative of 4x, which is just 4, equals, and then I have negative 10y, but remember, I just took the derivative of a y, so I write dy dx. All right, now we need to be just a little bit careful right here, okay, because what I have here is 2 variables, but they are being multiplied together. So we got to be very careful there. Okay, so I'm going to do product rule here. Now, I also have a complication here of a minus sign. I'm going to show you how to work through that. Okay, maybe you don't realize it's a complication, but it is. So I'm going to put that minus sign, and then I'm going to open up a set of parentheses, and I'm going to do product rule. So remember, product rule is the first times the derivative of the second. Now the derivative of y is just a constant 1, but you just took the derivative of a y. So I'm going to write, oops, I thought I had my pen on there. So I'm going to write dy dx. Okay, so just to recap, first times the derivative of the second. Now I'm going to do plus the second, which is y, times the derivative of the first, so the derivative of x squared, which is 2x. Now I know that that looks ugly the way I'm writing it. I'll fix it in a minute, I promise. Okay, so I just did my product rule. So again, I did the first times the derivative of the second plus the second times the derivative of the first, which is 2x. Okay, and now the derivative of plus 4 is just 0, right? So I don't have to write anything else. All right, now about this minus sign, now I would like to distribute that through. So I'm going to have a negative in front of this, and I'm going to have a negative in front of this. Okay, all right, so let me just rewrite that. So that's going to give me 4 equals negative 10y dy dx, and then that's going to be minus x squared dy dx. And I'm going to rearrange this last thing to make it look a little bit prettier. Let's put things in order. 2xy. Okay, so now remember when we have something like this and we have more than one dy dx, we like to get the dy dx on one side, and we like to get everything else that doesn't have the dy dx on the other. Well, these guys are already on the right, so I'm just going to leave them. So I'm going to move this guy over here with the 4. And since it's positive, moving it to the other side is going to make a negative. So I'm going to have 4 minus 2xy equals negative 10y dy dx, and then minus x squared dy dx. So now you can see that all my dy dx's are on the right-hand side. So remember when we do implicit differentiation, on the right-hand side there, I'm going to factor out that dy dx from both of those terms. And when I do that, I'm left with negative 10y minus x squared. And then everything pretty much just stays the same right here on the left. Okay, now we want to get the dy dx by itself. So I am going to divide out that negative 10y and then minus x squared. Okay, and then we're going to divide that on the other side obviously as well, so that that cancels out. All right, I'm just going to flip-flop this around. So then dy dx is going to be equal to 4 minus 2xy over negative 10y minus x squared. Okay, now if you read the directions, they're asking you to evaluate this derivative at this point, 5, 1, so that we can find the slope. All right, so just like the last one, vertical line, x is 5, y is 1. And that's all we're going to do, is we're just going to plug in 5 for everywhere we see an x and 1 everywhere we see a y. So I'm going to do 4 minus 2, x is 5, y is 1. Then in the denominator here, I have negative 10, y is 1, minus 5 squared. Okay, so let's keep going here. So I have dy dx equals, evaluated at 5, 1 equals. All right, so in this numerator over here, I have 2 times 5 times 1, which is 10. So that is 4 minus 10. And then in the denominator, I've got negative 10 here and 25 there. So that is going to give me negative 10 and minus 25 there. Okay, so what do we have in the numerator? We've got negative 6, and then in the denominator, negative 35. Okay, so this is dy dx evaluated at 5, negative 1. Now, I just noticed that that's a double negative, so let's make that 6 over 35. So to me, that would be your final answer for the derivative evaluated at 5, negative 1.